Okay, our essential question for this lesson: how can we solve a system of equations using elimination when the coefficients are not opposite of each other? So what I mean by that, if you recall in the previous video and lesson, we did something like 3x plus 2y equals 12, negative 3x plus 6y equals 16. So something like that, where in one case of your variables, you had coefficients that were opposite of each other, so then you could just add the two equations and that variable eliminates. Now what we're going to do is look at equations like the one you see here, in which case the numbers in front of the x and y variables are not the same and they're not opposite of each other. So then how would we solve something like that? So I have some questions over here for you to think about. Okay, so you kind of have to think about, okay, what are we looking for when we're solving by elimination? Gave you a little bit of a hint above, right under the essential question there. We're looking for two of our variables, like right here, to be opposite of each other. One is positive, one is negative. The number part is the same. So positive 3, negative 3, so that they will cancel out. So then the next thing we have to think about, okay, looking at these equations, do we have what we need with the equations, how they are? So if I look here, I have a 2 and a 4. Well, they're not even the same number and they're not opposite of each other. Look here at the y, I have a 1y and an 11y. So again, they're not the same and they're not opposite of each other. So it has to be the numbers in front of the variables that we're looking at. So since we don't have what we need, the next question is, how can we get what we need? So what can we do to these equations so that we do have numbers that are opposite of each other, so that when we add the equations, they will cancel? And so the answer to that question is multiply. So you can multiply one of the equations. So there's a couple of different ways. You have to decide which variable am I going to eliminate. In my case, I would probably try to eliminate the x variable here, but you could eliminate the y variable. Either way, we would only have to multiply one equation. So if I decide to eliminate the x variable, what do I have to multiply that equation by so that my x's will be opposite of each other? Okay, so if you multiply by a negative 2, okay, so we have negative 2 times the 2x plus y equals negative 9. And then distribute, so I'm going to multiply everything, including the constant at the end, by that negative 2. So negative 2 times 2x gives me negative 4x. Negative 2 times y gives me minus 2y. Negative 2 times negative 9 gives me positive 18. So I took the first equation and I rewrote it. Now, put right below that the other equation. Please keep the two equations next to each other. So now, if you look at your variables, the x variable does have a coefficient that is opposite. So we're going to go ahead and add our two equations. Negative 4x plus positive 4x gives me 0x. So then we look at our y, so our x variable canceled. Negative 2y plus positive 11y gives us a positive 9y. And you have 18 plus 9, which gives us 27. Divide both sides by 9, you get y equals 3. So once you get one of the equations or both of the equations so that you have the opposite coefficient for one of your variables, the rest of the process is exactly what we did in the last lesson. So then we've got y. We need to go back and find x. So pick one of the original equations. So I'm going to go ahead and use this first equation, but I have to use the original. So that's 2x plus y equals negative 9. And I know what the y number is, so I'm going to plug it right in there. So my y number is 3. So 2x plus 3 equals negative 9. Solve for x. So 2x equals negative 12. Divide by 2. And we get x equals negative 6. So now I have my x value is negative 6. My y value is 3. So the solution is negative 6, 3. Don't forget to do your check. You need to check that makes sure that the answer is correct, and it does work in both equations. And remember, you have to start with the original equation to do the check. So I wrote down both of the original equations, and now we're going to plug in our numbers. So x is -6, so 2 times -6 plus my y is 3, so I put the 3 in the y spot, equals -9, so that's -12 plus 3 equal to -9. This is what I'm checking. Does it equal -9? -12 plus 3 is -9, so -9 equal to -9 does work. Now checking the other equation. 4 times x is -6 plus 11 times y, which is 3, equal to 9. So then we're going to simplify that. So 4 times -6, -24, plus 11 times 3 is 33. We want to know, does that equal 9? So -24 plus 33 is 9. 9 does equal 9, so it does work in both equations. So -6, 3 is our solution. Now, here's another example. So you want to look at the variables and decide which variable you're going to eliminate. Now, in the first example, we only multiplied one equation. Sometimes you're going to have to multiply more than one equation. So you look at your x's. Is there anything I can multiply the 9 by to make it equal to a 2? Okay. Nothing nice. You'd have to use some fractions, and that can get messy. Same thing with the 2. Is there anything I can multiply the 2 by to get a 9? Again, you'll have to use fractions and decimals, and that could get messy. So to keep everything at whole numbers, multiply both equations. And one of the things you can use are the coefficients that are given. Use the 2 on top. I'm going to make that a -2. Use the 9 on bottom. I'll make that a +9. Now, the reason I made one of them negative and left the other one positive is because I want to have the opposite value in front of the x, so that when I add the equations, they will cancel out that variable. So now we're going to distribute. So -2 times 9x is -18x. -2 times the -8y. Careful with your positives and negatives. That would be a +16y. -2 times 4 is -8. Now we're going to do the bottom. 9 times 2, 18x. 9 times 3, again, be careful, there's that minus there in the front. So that'd be -27y. And then 9 times -4, -36. So now if you look at the x values in the front, the coefficients in front of the x, they are opposite of each other. So if I add the two equations, -18x plus +18x will equal 0. Then I have 16y plus -27y, so that's -11y equals -8 plus -36, which is -44. Again, you have to be careful with your positives and negatives. All right, so now we divide by -11. So y is equal to 4. Pick one of the original equations. So I'm going to use the 2x minus 3y equals -4. Take the value you just found, y equals to 4, and plug it into the equation for the y value. So 2x minus 3 times 4 equals -4. So 2x minus 12 equals -4. Add 12 to both sides. So we get 2x equals 8. Divide by 2. X equals 4. Write your final solution, in this case, 4, 4. And then we'll do our checks. Now, I have a couple of special cases on the next couple of slides, so we're going to explore a little bit and look at what happens and get you thinking about these kinds of special cases. So if you look at those equations, we've learned a number of different methods. We've got, you can solve the system by graphing, you can solve the system by substitution, you can solve the system by elimination. So you have to be able to look at an equation and determine which method, if I don't ask you for one specifically, which method is most appropriate to use. Sometimes one is more convenient than another. So you have to figure out which one is most convenient. Typically, if you look at an equation and you have all your variables lined up, the x's are lined up, the y's are lined up, the equal signs are lined up, you have a constant lined up. If everything is all lined up, elimination seems to work best. Okay, so we can use elimination. You might have to do some multiplying to get there, but usually it's the most convenient. Okay, so we're going to use elimination for this. So let's solve the equation and see what happens. So since my x variable right here has the same number in front, I'm going to subtract the two equations. So the 2x minus 3y equals 6 minus the equation 2x minus 3y equals negative 4. So I'm going to rewrite them. So the top equation, I'm not doing anything to that one, so I'm just going to rewrite it. Bottom equation, I'm actually going to distribute my subtraction to see what happens. So it's minus 2x, and the two minuses, the minus here and the minus there, become plus 3y. And then I have the minus in front and the minus on the 4, so that becomes a positive 4. So 2 minus 2 is 0. Negative 3 and a positive 3 is 0. So I ended up with 0 on the left-hand side. On the right-hand side, 6 and 4 gives me 10. We just lost our variables. There's no x, there's no y, they both canceled out. I have 0 equals to 10. Does 0 equal 10? No. Those are not the same numbers. So if those are not the same numbers, then what do you think that means for the solution? Okay, if you get something that's not equal, and we've lost all our variables, this would be a no solution. Okay. Now, try to think back to what the graph might look like for a no solution. Remember, we did some solving with graphing. What kind of a graph gave you a no solution? Okay. Hopefully you remember if we had parallel lines, that means they don't cross. That means you can't find a point of intersection because there is no intersection. The lines don't cross. So that would be a no solution. So if you know you have a no solution, the graph should have parallel lines. Let's look at another special case. We're going to solve using substitution or elimination. So which method should we use? So in this case, if I look at it, my variables are not lined up. I don't have the x's lined up with the x's, the y's lined up with the y's. We don't have anything lined up. So I look for the next thing. I do have a variable that's all by itself. That variable is equal to 2x minus 4. So since I have a variable that's all by itself, we can use substitution. Okay, substitution is a more convenient method when you have the variable that's all by itself. Now I might still ask you to use elimination, and if I ask you to use elimination, then that's the method you have to use. But if you get to choose, these are some of the ways that could help you find the most convenient. A variable all by itself on one side means substitution is a more convenient method. So I'm going to plug that into the other equation for the y variable, because that's what it's equal to. So 4x minus 2 times y equals 8. I'm going to plug that, what the y is equal to, plug it into where the y spot is. And now we're going to simplify. Okay, so we're going to solve the equation and see what happens. So 4x, distribute. It's negative 4x, distribute. That'd be plus 8 equals 8. Now combine like terms. What's 4 minus 4? Well, 4 minus 4 is 0. So I end up with 8 equals 8. We lost our variables again. Okay, so I don't have any variable. So now we look at what we have left. Does 8 equal 8? Well, yeah, it's the exact same number. 8 is always going to equal 8. So yes, this equals 8. So what kind of solution do you think we would have if we've lost all our variables and we have something that's always true? 8 is always going to equal 8. And that's an example of many solutions. Okay, so this is our many solutions example. What do you think the graph's going to look like? So remember back to our graphing lesson where we had some graphs that did give us many solutions as our answer. So what did those graphs look like? Okay, so what that graph looked like is just one line on the graph. Okay? The two equations above give the same line. So it's one line on top of the other. So those two equations, you can plug any number you want into the x spot for both equations. It's always going to give you the same y value. So that's another special case. So we have those two special cases, the parallel lines, which give you no solution, and then when you end up with just one line with two different equations that give you the same line, which means many solutions. So here's kind of a summary. This is in your textbook, so you can take a look at that. You don't necessarily have to copy it straight down from here. So you'll find it on page 462. These diagrams, they give you the examples of types of solutions that you can get solving systems. Got the case where there's one solution. The lines intersect at a single point. Okay, so then you would identify what that point is. You have the no solution, which means your lines are parallel. So you have two lines that do not intersect. Then you have the infinitely many solutions, which means the two equations give you the exact same line. So if you look at the graph, there's only one line on the graph. And then we have three different methods that we are using to find these values. Okay? The graphing, substitution, and elimination. So those are the methods we have for finding the solutions, these three types of solutions. So this is the practice that you're going to do at the end. So there's a couple of questions at the beginning. So on the left side of your notes, make sure that you answer each of these questions. Okay, so try to list 3 ways to solve a system of linear equations. List 2 special cases of systems. And then what does a solution for a system of equations look like? And then if you're looking at a graph, what are you looking for to find the solution to your system of equations? And then I have 2 equations here, 2 systems of equations that I would like you to solve using elimination. These are like our earlier examples in this lesson. And we will go over all of those in class next time.